that we can see the surface on the sides. So we have the top one, right side, left, and the round one. That should be surface. And if you compare, the element should be shell element, right? And the structure here should be beam element. And for this one, it's a gusset. We can use solid. Okay. And on the plate, bottom there as well, yes, it could be solid. Okay. So hopefully this one will complete resolve because it's a small one, small problem, small element. Okay. So on this one, the material will be aluminum 5052 H32. And on this structure, we assume that we will have a point load here. So in this case, we're going to apply a point load on beam. And let's say how we're going to apply the load. Concentrated load, point load there. And also we have a distribution load on this beam and the other beam here. Okay, the distribution load that you already said, you have said it before, you know how to do that. But for the point load, yeah, that you will learn on this lesson. Okay, so let's set up the simulation option. Check the unit. Okay, that's correct. Match high quality. Okay, that's it. And then check the configurations. Okay, we have only default one, and we have an explode view now. If you don't like, we can correct. But for working easily, when we pick up the surface, that just use an explode view first. And then we go to create a new static. Let's say that is static 2. Okay, create static. And then for the part, let's check that we have this will be the base. This is the cabinet structure. And we have the gusset number 1, gusset number 2, and we have the surface skin on the left one, the round one, the right one, and the top one. Okay, we already have it. Okay, so let's apply material. Part, apply material to all, and I say it's aluminum. So this is steel library. We go to aluminum alloy and 5052 H32. And let's apply and then close. Okay, all material, aluminum 5052 and H32. Okay, and then we will define the different type of elements by say something is shell, something is solid, and something is beam. Okay, for the base, just keep it solid. For the skin, let's say define shell by selected face. Okay, and I select this, full surface, full skin. full skin. And let's say the thickness is in millimeter. Let's change the unit here. In millimeter, it should be 2.54. That's a 0.1 inch. Or you can just change the unit to be inch. That will be 0.1. Yeah, that's the same. Okay. And on this one, let's say, so the previous one, we have tried the gusset, which is solid, but on this one, let's try to define the shell on gusset. Yeah. Just for fun. Yes. I will change the gusset to be shell. Could be, because the gusset is thin enough, and let's say the same thickness, 0.54 or in inch will be 0.1. That will be the same when you change the unit. Okay. So for the gusset, actually it's a small difference when you treat it as a solid or treat it as a shell. Just small difference. If you think that is important in your considerations, it depends on you how you define the gusset to be solid or shell. It depends on you. Just a small difference. Okay. Okay, let's check. The base is solid. Okay. The gusset and the skin will be shell, and inside the carbonate structure that's already set as a beam. That, as we can see on the icon, that shows beam. And what is this one? They also have some of the structure inside here. Yeah, which is not this structure. It's another stuff that contact with your structure. That would be a solid body. Yeah, without change. Okay, that's all shape. And then when we have a beam structure, the joint group we show on the model 3, and then we just click on edit. And they will show us all the connections of beam. Yeah, that's have 8 joints. Just check for make sure that it is connect. The beam is connect. Okay. Are recalculated? Look the same. Okay. And then we go to your applied material. We have to create contact set. Okay, the step we have done the material, and we all change the element type to be solid, shell, and beam. And then we check the joint group between the beam that is already connected. And the next step, that will be the connections. The global connections will be automatically bond. And then for the auto set, which is we can create a contact set to make sure that all the elements can be bond. Okay. The contact set that we will do is to make sure that the structure and skin have contact. Okay, we go to bond conditions, choose the beam type, and select that beam on one side, and make sure that it's connect with the skin. So on this surface, choose skin. That skin will be attached and bond with the structure. Let's say OK. And do the same for the other sides. Create contact set. Change to V bond. Choose the beam type. And select the structure. Okay, underneath, be careful. Make sure you select the right one. Okay, that should be that blue one, which is the beam type. Okay, and another contact set be on the right side. Bond conditions, beam type, select beam. And the surface contact. And then don't forget to create a contact set of the gusset too, because now we set the gusset to be shell. So we have to create the bond between the structure and the gusset too. Bond. And another set. Bond and B type. Yeah. Which one? Above one. Oh, I forgot. Thank you. Yeah, we have the top skin as well. Yeah, thank you. That was thoughtful. And after the bottom one, we have to create a contact set as well to make sure that we contact the base, we contact with the structure. And also we have these pieces to attach with the frame. Let's create a contact set. things are cool enough. And then we do the fixed geometry. Fixed geometry. And we will fix all that 4 holes. That will be a fixed point. Fix on holes. Fixed geometry. Okay, that fixed geometry. And then now apply load. So we have force, as I say, we have a concentrated force at a point. So load, force. And then we have a force and the type, let's say joint. We will apply on this joint. Okay. And we have to select the reference plane to say the directions. So it's surface from top, let's say top. And that I would say normal to top. And that will be the load of 4,500 Newton. And the directions, let's check. I need it to go down. I need to reverse direction. Can you see the arrow here? See, the arrowheads go down. I can just change the scale here to be bigger. You can see the arrowhead, maybe 300. Yeah, that will be the point load on that joint. And the directions is down. Okay, and that is concentrated load. And then we also apply a contributed load on beam, that force, and select beam type, and we can select that beam, 2 beams. Two beams there. And then we have to select the reference plane to apply the directions. So let's say the top plane again to be reference, and the directions is normal to, and move down. The arrow is moved down. So check the arrow. And let's say the force is 4,500 again. Okay, that's different type and different way that you can apply the load on your structure. Apply on the joint or apply on the beam. That will be concentrated load or distributed load. That's different. Okay, that's it. And then we can create mesh, and then the same. If you would like to make the beam elements smaller, you can use the mesh control to adjust the element size of beam. But if you don't want, just let the program generate mesh automatically. Yeah, just say create mesh for Go. Okay. For me, just mesh control first. I will control the mesh for that's it. To be a small one, let's say on millimeters. Now is 26, but don't want to take that long time. Let's say just a minute. and you can also control on the beam. Yeah, you can select type for beam, and yeah, just control, for example, control just 4 beams here. And the size of element in millimeters again, let's say 20, not too small. And then create the global mesh. Yeah, let's say standard. And let's say size in the millimeters. Yeah. Let's say cross me. Don't want to take long time. Okay. I will go cross there. Some cabinet model mesh failed. Refining mesh reduce the overall element size. Okay. So some problem when we control the mesh and it's fine and mesh on that cabinet. Okay, let's just change a little bit. Definitions. Let's say that's too cross as well. And this one, let's say cross. Create mesh again. That still have mesh fail. Base 2. For base 2, let me check. Let's control mesh on the base 2. That better. Okay. That I choose the basis to cross, that I get it like this. And then let's show the view, collapse view. Okay, collapse view. And then just run. Strong combination. And then just run. Yeah, that's it. What we have. That show the results in displacement. This is a stress. If I say define stress plot, and let's say only beam, and also render the beam profile, show an axial and bending, then the trend. That will show just the axial and bending stress or the beam only. And if you don't want the scale of the informations, you can change to be a true scale. That's the true scale. Okay.